Are there any questions before we start?
When is the exam supposed to be?
It'll be next week, probably Thursday, just to give you more time. But let's see, I don't even know what days of the week we are on anymore. I've lost track.
It's Tuesday today.
Well, yeah, I know it's Tuesday, but as far as yeah, it's supposed to be the 22nd we take the exam, but I think if we go ahead and put it out to the 23rd, that gives you an extra day to do it. And I think what we have after today, we'll have two more sections to cover. And so that'll probably put us on Monday and Tuesday. And then Wednesday, maybe we could do some kind of in class review. And then Thursday, have the exam if we do it that way.
I like that idea.
And then tomorrow, and as you notice, I said today we'll finish 3-8, and then we'll have 2-4 and 4-3 or something like that. I forget the numbers now in the other book. And then so tomorrow, instead of actually a lecture, what we'll do is we'll do an in-class quiz, and that's probably what we'll do there. And I don't know if
Is
I'm.
the quiz over to is the quiz over the stuff that we've done so far, and we're also learning the stuff from the new book?
It'll be the exam will be everything that we've learned so far, plus the things we cover on Monday and Tuesday from the other book. And so it's basically with the other book, I think the other sections are inequalities. And so basically doing the same kind of stuff we've been doing already, but just with inequalities. So
Okay.
that's the only difference.
Um, and so tomorrow is just a quiz over everything we've done so far.
I think probably up to maybe the dividing polynomials, maybe. So what is that? Three,
That's
five.
3-5, I think.
Yeah, I think 3-5. So maybe only up to there, and that way we can kind of, make sure everybody's, up to speed with that, and then from there, next week, we do the next two sections after on Monday and Tuesday, and then Wednesday we can do any review or any other catch up we have to do if we didn't finish those two sections, and then we can have the test on Thursday.
And then before the weekend, would there be any way for you to like throw together some question numbers from the book for us to practice with? Because like the practice in the myopen math isn't very representative of anything that we
Yeah,
do in
it,
class.
pretty much it's going to be, I think, with this chapter, if you really look at it, it's going to be things like all the odd numbers, basically. So it's
Okay.
anything that's odd in the book. That way you can look at the answer. That's going to be kind
Okay.
of the key. So whether it's
But not past 30, right? You said those
well,
ones.
on there was that was on that was in that was on the last test. This test, it's not quite that bad as far as past 30 because some of them go up to 80 and 90, and really none of them have been too bad. So I think there's some sections that we probably don't really have, like some of the extension sections and technology sections. Those probably you don't need to worry about, but any application and anything else that's covered in the section we do, then I think would be basically fair game. So like on I think each of the sections in our book, um, the verbal one, there's like verbal, and then they have algebraic and graphical and technology and extensions and real world applications for this section. So I don't think the verbal or the technology or the extensions really would be things that we need, but the algebraic, the graphical, and real world applications would be. Now let me see what another section says. Yeah, so algebraic, graphical, and real world applications are the key ones. The technology, the extensions, and the verbal we really don't need. And that's pretty much how they always are set up, it looks like, for this chapter. So
Hmm.
uh,
Okay.
so yeah, so I think that's gonna be kind of the way to look at it. Now under the algebraic and under the graphical and stuff, they have, there's going to be some technology in some of those, but there's a section labeled technology and there's a section labeled extensions, and I don't think those are going to be very easily tested on most of the tests for online, and the verbal. And it's good to know this stuff, but as far as being tested on it, I wouldn't do that. But anything under the algebraic, graphical, or the applications would be fair game, basically.
And if you're putting the test in my open math, right? Is how you're going to try to do it.
That's my goal. That's what I have to do this weekend to program it in there, because you have to actually program the things to make it work in there. It's really a royal pain. I just did it for one of my other classes for a test this Thursday, and it took hours to get it in, and I only had 13 questions, and they were simple ones too. They weren't even difficult. So, yeah, it's something that's gonna it'll take some time, but my goal is to put it into Mom, and that way when you get in there, it's just in Mom. You can
And we'll
just
know
do it.
our answers right away, right? Like,
Yeah, it should grade all your answers right away, and you know what you did if you got it right or wrong. So,
but it won't give us three tries like the.
no, it'll just give you the one.
Cool. Okay.
Yep.
And that's all I got.
All right. Anybody else? All right, so let's go ahead and start. So today we're doing 3.8, which is inverses and radical functions. And really, we've done this, already before. I think it was 1.7. And so with those, we basically try to find the inverse. And so things to remember from 1.7 is when you get your function f of x or g of x or whatever it is, you have to make sure it's one-to-one. And then if it's not, then you have to make sure your domain is changed to make sure it becomes one-to-one. So, if you have, I don't know if I can get my the x squared, that's not one to one because you draw a horizontal line and it breaks it twice. But if you start here, and if it's just x squared, then if you cut it and you say x is going to be greater than or equal to 0, then it's going to be everything over here only, and then it will be one to one. Or if you want just the side over here, then x is less than or equal to 0 to make it one to one. So you have to set your domain so it becomes one to one. So that's going to be kind of like your first step. Then after that, you solve for your x, then you interchange your x and y. And once you've done that, then you can label the new function f inverse of x. And so in replacing y, you put the f inverse of x. And then if you have to, revise your formula to ensure outputs of the inverse function correspond to your restricted domain up here. So, sometimes you might end up with a plus and a minus square root, but because it can't be a negative, then you only are going to take the positive square root. And so you kind of have to kind of look at things like that. And for this section, really, there's two key points. We're going to be working with quadratics, and we're going to be working with radicals. And so with finding the inverse of a quadratic, we have to be sure to limit ourselves to a domain where the function is one-to-one. So kind of like what we did up here, you have to make sure you only look at one side of it, either the left side or the right side. And then the other one is the inverse of a quadratic is going to be a square root function. And so, it's going to have something that's going to go like that. And so when you limit it to here for only the positives, then it's going to be like that as far as your function for the square root. And both of these are toolkit functions as well as their power functions. So that's kind of another key thing to remember, that we've been working with these. They're in our toolkit. We know what they are, and we know how to transform them up and down, left and right, things like that. And so we can usually graph these pretty easily. And then the next thing is the verification of functions that are inverses. Basically, you're just going to plug in one of the functions into the other one. So g of f of x is going to equal f of g of x, and that's going to equal x. And if you do it one way, it's going to work both ways. So you don't have to do both of them. You only have to do one. And as long as you get x out, then you should have a inverse. So just doing one or the other will give you verification that it is inverse. And so really, the rest of today is just practicing inverses and doing applications. So uh, first off, we're going to find the inverse of this function. And so what we need to do is we're going to replace f of x with y, and then that's the cubed root of x plus 4. Now we need to solve for x. So to solve for x, we have to get rid of this cubed root. So basically, we have to cube both sides. When we do that, we get y cubed on the left. And over here, the cubed root cubed gets rid of it, and we get x plus 4. Then we'll subtract 4 from both sides. And then if we go ahead and bring the x over to the left, we get y cubed minus 4. Now we're at the stage where we just swap our x and y. So now we say y is equal to x cubed minus 4. Now we can say, well, that's the f inverse of x is x cubed minus 4. Now, if you'd graph this to make sure it was one-to-one, you would find that both of these are one-to-one, and we don't have to worry about, restricting the domain on either one of those. So that's kind of a nice thing. Again, when you're doing that, maybe the calculator is the quickest way to do it. If you have something weird like this cubed root, and you can just plug it in your calculator and take it out and make sure it is one-to-one, and then you can just finish your problem from there. You don't have to actually worry about a domain if it's one-to-one. All right, so the next one, here we have a restriction. And so our restriction is x is greater than or equal to 0 because, this is x squared, and basically we've just moved it up 1 because we have the plus 1. And so instead of being right on the axis here, it's going to be just moved up 1 point up here. And so that's going to be what we have. And so to be one-to-one, we know that we're going to go on that side. So we have to start at x greater than or equal to 0. And if we think about it, well, what's going to happen is we're going to get some, all right, go back. Where'd it go? There it is. We're going to get a square root kind of function. And so it's going to look something like that. And so when we get done, hopefully that'll be what we see. We're going to get a square root. All right, so if we go ahead and then we substitute the y in for f of x, then we get x squared plus 1. Now we subtract 1. So y minus 1 equals x squared. Now we just want x, so we have to take the square root of both sides. And when we take the square root of this side, we have to say plus or minus. And now if we bring this over, we get x equals plus or minus the square root of y minus 1. Now we flop these around, so y equals plus or minus the square root of x minus 1. Now, when we think about this, can we have both the plus and the minus here? Well, not really, because if we have the opposite, then it's going to give us going to the left, and then it's not going to fit our function here. So we just can only use the plus, and so we're restricted to the plus only. And so then when we rewrite it, f inverse of x, that's just going to be the square root of x minus 1. Now, where is this one actually going to be true? Well, here x has to be greater than or equal to 1, because if we have 0, that makes it a square root, and it's going to be an imaginary number, and anything low is going to give us an imaginary number. So everything greater than or equal to 1 will work, and we should get a number or a graph that sort of looks like that, where you've got your shift there, except it's not gonna be that way. You're gonna have the square root of x and minus 1, so it's gonna be shifted to the right instead of down. I just kind of was showing you the square root here, so that's not really where it's gonna be. It's gonna be shifted to the right. And so then when you draw your y equals x, hopefully you've got the reflection across there. All right, let's look at another one. Okay, square root of 2x plus 3. All right, do we have any restrictions here? Well, here we have to say what's underneath our radical is going to be greater than 0. So what we say is 2x plus 3 has to be greater than or equal to 0. So if we subtract 3, then we have 2x is greater than or equal to negative 3. So 3. And so we divide by 2, so x has to be greater than or equal to negative 3/2. So we have that restriction on our original one. So this one, they didn't tell us the restriction, so we had to come up with our own. And so now we say, okay, well, y is equal to the square root of 2x plus 3. Now we want to solve for x, so what do? Well, we have to square this, so we square that. So y squared equals, that just drops, we get 2x plus 3, subtract 3, y squared minus 3 equals 2x divided by 2. Now if we bring our x over here, we get y squared minus 3 over 2. Now we can swap out our x's and y's. And so y equals, then we have x squared minus 3 over 2. Now we can replace our y with f inverse of x. And that's x squared minus 3 over 2. And here, what do we have to have? And so this is going to be the x squared. It's going to be shifted. And so basically what we have to have here is we have to have x has to be greater than or equal to 0. Okay. Now, if we want to graph this, we can graph our original and our inverse. And so let's go to our calculator. Let's say, so we had square root of 2x plus 3. And if we did our second one, we had the quantity x squared minus 3 divided by 2. And if we put in our y equals x line to kind of look at the angle, then we can graph this. Now remember, we restricted the first one to greater than or equal to -3/2, and so that's kind of what we see here. That's going to be our -3/2, and so it's going to be everything greater than that. Now the second one we said had to be greater than or equal to 0, and that would be because over here that's not 1-to-1, and so it has to be on this side, so it's just that piece. And so then when you split that up the middle, this and this, that's going to be the mirror image. Now there's one cool thing that works. Let's put it onto our second one here. And we can put our restriction. Now the first one, we don't need to put a restriction because it automatically does it for us. But this one doesn't. And if we say divide by, and then we put our restriction, x, now it has to be greater than or equal to. So now we got to go in here and find greater than or equal to. And then enter, and we said it had to be greater than or equal to 0. What this does then is it restricts it to whatever we told it had to. And so now this looks more like what it should. It gives us only the one-to-one function here, the one-to-one function here, and then our y equals x line here. So that's kind of a cool feature of the calculator where you can actually set your limit as far as what it's going to draw. And so anything less than that, it's not going to draw. And so it doesn't put it here, but it puts everything else over here. So that's kind of a nice feature that we can use if we want to draw a picture and see what it looks like for the true inverse.
So do we have to write, like if that was a test question, would we have to write the x is greater than or equal to 0? Like, is that just like the domain?
Yeah, so this is going to be, this would be what you'd have to put on your final thing. So you'd have to have,
Does the x,
yeah, your x has to be greater than or equal to 0, otherwise you're going to get non-one-to-one. And we want our function here to start being one-to-one, and then when we get done, this has to be one-to-one as well. So, you know, technically you would really have to find out the first piece where it's one-to-one, so we'd have to know this, so you'd have to know that part. And this one, we'd have to know that it's one-to-one only in that area. And so you'd have to kind of do both of those to show your one-to-one functionness, and the inverse is how they would be one-to-one as well.
okay, how do you know it's only 1-to-1 at the x greater than or equal to 0?
Well, because you know, when we drew that picture over here, when we had the whole thing, it went up here. And so to be one-to-one, when you do a horizontal line, it can't cross it twice. And the only part where it starts is at the 0. And so that's going up here is going to the right. And so then we had to know, we knew it was going to be greater than or equal to 0. So starting here and moving up was going to be where it was one-to-one. And that's because we had this one originally going from the -3/2 up. And so when you plug those two in and figure it out, what happens is, let me see if I can annotate here. I don't know if I can. Doesn't look like anyway. But anyway, so what would happen is you just have to figure out where it's 1 to 1, and it's only 1 to 1 starting at that position right there. Now, if we'd gone, and said, well, we want everything less than or equal to 0, that would go up here like this. And we wouldn't have this red line. But then that's not going to be the inverse of this here, because then that's going to be coming up like this, and the inverse isn't. That's not the inverse we want. We want the positive one, which is this one that way. And so we have to have that piece there.
Gotcha. Okay, thank you.
Mm-hmm. All right, so let's do this one. 3 over the x minus 4. Well, this one there's no restrictions, because if you think about the 1 over x, it's doing something like this. So it never, and that's more straight out, but there's no places where it's not 1 to 1. So that's 1 to 1 everywhere. So we're no restrictions. And so we have y equals 3 over x minus 4. Swap those. And that's y minus 4. Now what we have to do is we have to take the y minus 4 over here, the x over here, so we get y minus 4 equals 3 over x. And you can just think of that as, the cross product and then dividing it out is what we've done. So that's how we've got that. And what did we do? What are we doing? Now I've talked too much and I forgot what I'm doing. Oh, I'm solving for y. And so then I add 4. And so y equals 3 over x plus 4. Now I can say, well, let's find it and replace that with f inverse of x. And again, this is going to be in the shape of basically our power function up here. And so we don't have to worry about the one-to-oneness. And so then that's just our final inverse, 3 x plus 4, 3 over x plus 4. Okay. All right, so this one is a little bit more in-depth, complicated, and so this one is something that we kind of have to pay attention to. And so maybe our first thing is let's graph this and see what it is. And so let's go to our calculator, and so we can clear that one. We can clear that one. I'm going to leave the y equals x just because. And so now I have x squared plus 4x and then plus 1. And it said on the thing that it was going to go from -2 on up. And so if I want to do that, I can go ahead and say, I should probably go back here. Is what I should do. And shift insert, put my parenthesis, go all the way to the end, then insert, and then divide by, and do the same thing I did before, and put what my restriction is. That way I know what it really looks like with what I'm doing. So it's going to be greater than or equal to, and I forgot the x, of course. And it was greater than or equal to -2. All right, so now let's look at that graph. So this is what our graph is looking like. That's what they said our restriction was when it was x is greater than or equal to -2. Now, if we had gone ahead and drawn that out, that would be up here, and that wouldn't be any difficult. So, but that's our restriction. And so now let's go ahead and find out what that inverse looks like. So that says y equals x squared plus 4x plus 1. Now we're going to swap the x's and y's. So x equals y squared plus 4y plus 1. Now, this is one of those that's going to be kind of strange because we really can't solve for just y as it is. And so what we're going to do is we're going to do a trick and subtract x from both sides. And so 0 equals, now we have y squared plus 4y plus 1 minus x. And we're going to think of their part as our c. The 4 here is our b, and then this 1 is our a. And what we're going to do is we're going to plug that into the quadratic formula and solve. And so we're going to have y equals, because we're solving for y, and it's going to be a minus b, so minus 4, plus or minus the square root of b squared, so it's going to be 16 minus 4 times a, which is 1, times c, which is 1 minus x. all over, and then we have 2 times 1, which is our a. All right. So this was the tricky part here, is knowing that we needed to put our 1 minus x as our c, and then we could use the quadratic formula here. So now we're going to multiply this all out. Well, minus 4 times 1 is going to be a minus 4, and then we have to distribute it here. So we should go ahead and probably start writing this out as we go. So that's 16 minus. So we have a 4 times a 1, so it's going to be minus 4. And a minus 4 times a minus x, so it's going to be plus x. And that's still all over 2. Now, if we simplify over here, that's a minus 4 plus or minus the square root of. Now, 16 minus 4 is 12, and then plus x over 2. Okay. Oh, I lost my 4 somewhere because that's 4x. That's what I have missing. It's like, wait a minute, I should factor something. Now here I see that there's a factor of 4. And so what I'm going to do is I'm going to factor that out. And so then I have a minus 4 plus or minus the square root of 4 times, well, if I factor out a 4 out of that, I have 3. 4 out of that, I have plus x all over 2 still. Now I can take the square root of 4 times the square root of 3 plus x and simplify that. And the square root of 4 is just 2. So I have a minus 4 plus or minus 2 square root of 3 plus x all over 2. Now 2 will go into both of those. And when we do that, we get a minus 2 plus or minus square root of 3 plus x. Okay. Now, remember, we had a restriction that this had to be greater than a negative 2 there, okay? So if I have now saying that this is going to be minus 2 minus more, that puts this as, not going to work. And so the minus is not going to work. So only the plus will work here. And so that says then y is equal to a minus 2 plus square root of 3 plus x. And now what I can do is I can make that f inverse of x equals. Now, if I want to keep the negative 2 here, I can, or if I want to put it on the other side, I can. I've seen it, put both ways. When you put it this way, we for sure remember to have that minus 2 outside of this, because sometimes people are lax when they write it this way and then they say minus 2. And when you start putting that in your calculator, they keep that radical sign all the way over it, and then that gives you the wrong answer. And so putting it out front sometimes keeps it so when you type it into your calculator to make sure it looks right, then you have the right answer. Okay. All right. So what we need to do is see what that looks like as far as on our graph, to see if we need to restrict anything. And so going back over here, we put that in number 2, and we had a negative 2, and we said it was plus second square root, then we had x plus 3, and then outside, now we can graph. What did I do wrong? Oh, that's the wrong negative sign, that's why. All right, and so it looks like with what we have, we don't have to put any restrictions for that square root, and which is what we'd expect, because when you do the square root, it's always going to give us this top piece here only. It's not going to go down here as well, because then it's not a function. And so, that's just kind of how it works, because if you had that going down like this, then it's not an actual function. So this looks good as far as everything goes. So then we don't have any extra restrictions for our second one, and everything fits as far as it's reflected across that y equals x-axis, although the scale here isn't exact, so it doesn't look like that exactly equals that, but it is. Okay, so any questions on that one? All right, so let's move on. So here we're supposed to find the inverse, the domain, and then graph. All right, so with this one, they were nice. They actually told us the domain on this, and so then we just have to find the final domain to see what it is. All right, so y equals x squared plus 2. Swap those out. X equals y squared plus 2. Well, we have to solve for y. So x minus 2 equals y squared. And to get this y only, we have to take the square root of both sides. Remember, that's going to be plus or minus the square root. And so here we get y equals plus or minus the square root of x minus 2. Okay. Now, because x has to be always greater than 0, well, we probably should get rid of that negative because that's going to make it so it doesn't give us things that are greater than 0. And so really this is going to be y equals the square root of x minus 2. Okay. Now, are there restrictions on this? Well, with that square root, we can't have any positives or any negative numbers, so we always have to have this be positive under here. And so here, x basically is going to be greater than or equal to 2, because 2 will give us 0, and that's okay. But anything less than 2 will not work. So greater than or equal to 2 is going to be our domain. And we should probably go ahead and put our f inverse of x is equal to the square root of x minus 2 and x greater than or equal to 2. All right, so then graphing this, what do we have? Well, x squared, that's just going to be, this. X squared plus 2 just means, it's been moved up 2 on the axis. And with x greater than or equal to 0 means we're just going to do this piece over on the right side. So that is going to be the first one. Now doing the second one, the x minus 2, well, that says we're going to shift it right 2 and then have our square root. So if we shift it right 2, that's about 2, and we put our square root sign in there, that would be roughly what it is. And again, if we put our dashed line in the middle, then that does look like it reflects across that y equals x axis. And so that would be, our original function, the inverse of it with the domain on that one. And that's what we would have as far as our final answer. Okay. So any questions on that one? So when you have the x minus 2 in here, that's when we start having a restriction, whereas on the previous one we had x plus 3, so there's no restrictions here. Really, you don't want to have very big negatives, but we've already restricted it greater than the negative 2, so that was kind of putting our restriction on it there. So the new restriction is the one we have to put here. All right, so x plus 3, the quantity squared, x greater than or equal to a negative 3. All right, well, what do we have if we want to graph that first part? What do we have there? Well, this is going to be basically like x squared. Now our thing says, well, this is going to be shifted left 3 units. And then it says when we shift it left 3 units, it's going to still stay on this axis. And so, we're going to have a piece going up, and we're going to have a piece going up here. And the key is we're restricting it greater than or equal to negative 3. Well, negative 3 is right there where we restricted it. And so due to that fact, we really just don't have that piece there. And so we just have this right piece, okay? So that's the original function. So now let's find the inverse and graph that one. So y equals x plus 3, the quantity squared. We want to solve, or we want to swap the x and y's. We want to solve for y. So what we have to do is we have to take the square root of both sides. We'll have plus or minus a square root there. And when we think about that, do we want to have the plus and minus on that, or just the plus? Well, because of our domain, we don't really want a negative there, so we're just going to have only the plus. So use only the positive, and so that gives us a square root of x equals y plus 3. Now we'll subtract 3. So y equals, and now we have minus 3 plus the square root of x. And again, I put the minus 3 out in front just because if I put it over here, what happens sometimes is when you're typing it into, the calculator or when you're writing it, that square root gets so long you don't know if it's under the square root or not, and so putting it like this keeps you from having that issue. Okay, and so now if we change that to f inverse of x, we have that. Now, are there any restrictions on the square root of x? Well, x has to be greater than or equal to 0, basically. Okay. All right. So that's because, and we only did that because it's going to be different than this restriction. And so now we have the square root of x. Well, we know that that's just, like this, but we're going to go and it's shifted down by 3. And so now instead of being here, it's going down 3. And so we have that would be our thing. Of course, our -3 here and this -3 here is not quite, so it'd probably be a little further down, but we'll stay with our scale. That's right. And again, when you do your y equals x, it should be a good reflection across there as far as what it would look like. Okay. All right. How about I let you work that one? I think we have enough time to have you do that today. And once anybody gets it, they can holler out the answer.
Just for what the f inverse
Yeah, what's f inverse?
is it 1/2 x?
1/2 x. No.
No, I don't know what I did wrong then.
All right, so let's do this. First off, are there going to be any restrictions on this? Well, there shouldn't be, because if we think about it, if we can draw a line, it's going to be the same shape as 1 over x, but it's going to be 2 times whatever that is. So, normally if we had 1 over x is going like this and this, so where it used to be, 1 something, now it's going to be 1, 2, so it's going to be higher. So basically, it's going to be something that's like that. And so let's figure out, so the first one was just kind of what 1 over x is, and the other one's 2 over x. So let's find our inverse. So we're going to swap those. So x equals 2 over y. Now I'm going to multiply by y, divide by x. So y equals 2 over x. And so f inverse of x equals 2 over x. So guess what? Our inverse and our original are the same thing. So this is one of those tricky ones where your inverse is equal to the other one. And so if you really don't believe that, then what we do is we plug in 2 over 2 over x. So we multiply by x over 2, multiply by x over 2. So those all cancel. Now the 2 cancels and we're left with just x. Okay, so this is one of those special cases where you have the inverse being equal to the original. And so guess what? It's going to be the same line on top of each other. So did you figure out where you went wrong?
I guess I just don't get like why you get to just flip those like that. I
Oh,
guess.
because I'm just doing algebra in my head. So if we have x equals 2 over y, I'm going to multiply by y. And so I get xy equals 2. Now I divide by x. So y equals 2 over x. So I'm just kind of flipping them around because when you multiply like that, they just end up swapping places. And so we get that. And so again, all I did is to get this one rid of here, I multiply both sides by y. And then now I need to get rid of x, so then I divide both sides by x, and then you just have that.
Okay, that makes sense.
All right. So applications. When we're doing our applications, a lot of times you're gonna be working with radicals here. And so because we're usually working with times or distances, like some kind of measurements, usually we're not going to measure negative times or negative distances. And so usually there's always a special case somewhere you're going to find, but we need to use the appropriate sign. And so it's always going to be the positive square root because we need a positive distance or we need a positive time. And so that's a lot of these are all the applications are all radicals of some sort. And so what we're doing is we're going to just to take the positive radical. So we're not even going to consider the negative when we're doing these. So the first one says an object dropped from a height of 600 feet has a height h of t in feet after t seconds have elapsed such that h of t is equal to this equation, the 600 minus 16t squared. And what we want to do is express this now in terms of t. And so we want to solve it for t, so then it's a function of height. So we want t of h instead of h of t. And then after that, we want to plug in the height of 400 and solve for the time. So basically, all we're doing is we're going to say, okay, well, this is h equals 600 minus 16t squared. And we want to basically solve for the t. So to solve for t, well, I can do two different things. I can take the 16t over and the h over, so that might be the easiest thing to do first. So then I have 16t squared plus h equals 600. Now I can subtract h. So then I have 16t squared equals 600 minus h, divide by 16. So t squared equals 600 minus h over 16. Now again, I'm going to take the square root of both sides, but because I want time to be a positive, because you're going to, throw a thing or drop it. Once you drop it, that starts the time. And so you can't say I'm going to undrop it and go the other way. So we're only going to have positive square roots. And so time in respect to h is equal to the square root of 600 minus h over 16. Now they say, well, what if we have a height of 400 feet? What is the time? Well, we just have to say, well, t of 400 equals square root of 600 minus 400 over 16. Now we plug that into our calculator and we get square root of basically 200 divided by 16, and that's going to give us roughly, let's see where my mouse go. There it is, 3.54, and this is in seconds, I think, somewhere, yeah, seconds. So if you plug all that in and take the square root, you just get 3.54 seconds. Now, did it say what to round it to? No, so I'm just going to put it 3.54 and stay with that. If they'd said round it to the nearest tenth, then it'd be 3.5. If they wanted it to the nearest thousandth, then you could put it to the nearest thousandth. So, but just to the 3.54, that would be our value. And again, we just had to find this here function first by solving the original one for t. So basically kind of solving for the inverse. If you think about it, you're just solving for going the other direction. Okay. All right, so this one says the period t in seconds of a simple pendulum as a function of its length L in feet is given by t equals 2 pi square root of L over 32.2. Now what we want to do is we want to express L. So basically we're going to solve this equation for L as a function of t and then determine the length of the pendulum with a period of t equals 2. So basically we're just going to solve. So we have t equals 2 pi square root of L over 32.2. So first thing I'm going to do is get rid of the 2 pi. So I'm going to divide both sides by 2 pi. So now I have t over 2 pi equals the square root of L over 32.2. Now I need L by itself, so I'm going to have to square this side, and I'm going to have to square this side. So then I have t squared over 4 pi squared equals L over 32.2. I want to solve for L, so I multiply by 32.2, multiply this by 32.2, and so now I have L equals 32.2 t squared over 4 pi squared. Okay, and so that would be if we wanted to have it in terms of t. Well, I guess that's a capital T, not a little case t, so I better put a capital. So L of capital T is equal to that. And now they're saying, well, what is L of 2? So that's what we're looking for. So L of 2 is equal to 32.2 times 2 squared over 4 pi squared. Well, 2 squared is 4, so that cancels that. Now we just take 32.2 divided by pi squared, and we get L of 2 is equal to, and if we divide that out, divided by pi squared, that's 3.26, and this is going to be feet. And so that's what our final answer would be, is that many feet. And that's with the period of 2 seconds. And knowing all the rest of the stuff that was given to us for the equations. All right, so let's go to the next one. The next one basically says, consider a cone with a height of 30 feet. Express the radius r in terms of the volume v, and find the radius of a cone with a volume of 1,000 cubic feet. So again, they give us the nice formula. All we have to do is solve it for what we're looking for. So we want to find radius given volume. So we're going to solve this equation for r. So v equals 1/3 pi r squared h. So we want to get r by itself. So first thing I'm going to do is multiply both sides by 3 to get rid of that third. So 3v equals pi r squared h. Now it's easier to divide by pi h. And so then I get r squared equals 3v over pi h. Now I want the square root of both sides. And again, I want the positive number only for radius, so I'll just take the positive square root. So that gives me r, and it's going to be in terms of the volume, so v, and that's equal to the square root of 3v over pi h. Well, they said h is 30, so if I want to go ahead and put 30 in here now, I can. That's because they gave that to the equation. Now, what we want to do is plug in v as 1,000. So r of 1,000 is the square root of 3 times 1,000 divided by pi times 30. Well, some of those things cancel, but nice thing about calculators, you can just plug it all in. And so if I do all that, we get 5.64. So, where's my, there we are. R of 1,000 is equal to 5.64, and we're in feet. So that would be my radius for the volume of 1,000 cubic feet. Okay. All right, so that's all I have for today. So it was a short section with a lot of the stuff we've already done before. And so again, tomorrow, what we'll do is we'll have a quiz in class. I'll try to see if I can actually get it into Moodle or into Mom, and so then that'll get me practice getting those types of questions into Mom. And if not, if there's something I want you to have to draw, then you can do that on paper and take a picture and send it to me. So, any questions?